Hello, my name is Lilias Camacho. I'm in grade 12 from King's Christian Collegiate. I hope you're having a great day. Today I'll be talking about my project on determining the most affordable water filtration method for countries in need. Did you know that 785 million people in the world lack safe drinking water? And I got to thinking how lucky that in Canada we have 7% of the world's renewable fresh water. Other countries are not as lucky. This is why I did an experiment to investigate a method of filtering water that is cheaper and more efficient for emergency uses. Such information can be used towards developing countries that do not have access to clean water by making filtration more attainable or using these filters as a temporary method until a long-term solution is discovered or achieved. To do this, the first thing was to get different samples of dirty water. The first sample was from a normal pond water outside my school. Next was drinking water mixed with salt to imitate the ocean. So each sample was 500 milliliters and 200 grams of salt were added. And then lastly, another one was water mixed with calcium chloride. Again, each sample was 500 milliliters and 200 grams of calcium chloride were added in. And this was to imitate having high amounts of ions that are not always wanted. Next, we had to get a control variable, and therefore drinking water was tested using the methods of pH, ammonia concentration, nitrate concentration, total dissolved solids, and electric conductivity. The same thing happened with dirty water samples before they were purified to see after they were treated with the methods if the methods did purify the water or treat it a bit. So the first method that was used and created was the activated charcoal method. On average, carbon filter remove at least 81 pollutants and effectively decreases another 52. In addition, activated carbon is the only filtering method that removes all 12 herbicides and 14 pesticides, as well as 32 organic contaminants. So to create this filter, a bottle was used and the lid was taken off and holes were poked in to let the water go through, and then a filter was placed on the lid and screwed back on. And then the top of the bottle was cut off, and there were in the bottle layers of sand, activated carbon, small pebbles, large pebbles, and coffee filters were placed to make this filter. Then the next method that was done was chlorination, and chlorination has been used in pools and spas for many times now to keep the water clean and keep everyone safe. So to make sure that this was safe to drink, 2 drops per liter are safe, and you have to leave it for 15 minutes to sit. In my experiment, I did only 1 drop as it's 500 milliliters, and I left it to sit for 30 minutes just in case. So chlorine removes harmful microorganisms such as viruses and bacteria. The next method was adding iodine to the samples, and for it to be safe to drink, it's 5 drops per liter, left to sit for 15 minutes. In my experiment, since the samples were 500 milliliters, I did 2.5 drops per 500 milliliters and left to sit for 30 minutes. Lastly, the last method used was boiling, and each sample is boiled for 3 minutes on a hot plate, and boiling gets rid of some bacteria and contaminants. So the results, as mentioned before, the dirty water samples were tested initially and the drinking water was tested. So the drinking water got a pH of 8, an ammonia concentration of 0.25 ppm, and a nitrate concentration of 1.0 ppm. Since it was drinking water, it had a 0.0 ppm of total dissolved solids, but an electroconductivity of 94. So the first method that was tested and created was the activated carbon filter. It was really affordable as it was $12.96, and the filter was made by getting a bottle, taking off the lid, poking pen-sized holes in the lid so the water can actually go through. Then a filter was put on the lid and screwed back onto the bottle. The top of the bottle was cut off, and inside the bottle it was layers of activated carbon, sand, small pebbles, large pebbles, and coffee filters, leaving a bit of room at the top just in case the water does not filter as fast or as slow, so the water does not overflow. And after all the dirty water samples were filtered through, it was clear that they were significantly cleaner. The pond water had a total dissolved solids of 1,800, but after being filtered, it was down to 935. The electroconductivity was identical, as it started out with 2,560 and then went down to 1,920. Same with the calcium chloride sample. Initially, the total dissolved solids and electroconductivity was above 10,000, but then it went down to total dissolved solids of 6,840 and electroconductivity of 9,450 after being filtered. The salt water had not changed after being filtered, but for the salt water, the ammonia concentration did go up, by 0.24 and the pH by 1. In conclusion, other than the salt sample, the filter worked for the pond and calcium samples. So the next method that was tested was the sodium hypochlorite method. The result went up because another chemical was mixed into the equation. As seen in my data is the total dissolved salts and electrochemical rate went up for each sample because the bleach added more ions to the sample. But this does not mean that the method did not work out, as a limitation to this lab is that it's not possible to test if there's bacteria or viruses in the water and if they were killed after each treatment. If there were bacteria though, it could be assumed that the bleach killed some or all of it, and in the results, in the end, we do not know if it did make the water cleaner that way or not. Something that was able to be calculated was the price. So the price is actually really cheap. It's $5.94 per liter. And it's really easy to transport this method in a bag or container. The third method was adding drops of iodine to samples and waiting 30 minutes. Like the method was bleached, the results were higher than the initial results because of the ions added to the samples. Another thing that was different with this method was that it produced a small pH for the pond water, as it had a pH of 7 after. And the calcium chloride water had a pH of 6 and the salt water had a pH of 7. A good fact about this method is that the cost per liter of one bottle is $21.23, making it last over a very long time, as you only need 2.5 drops per 500 milliliters. The last method used was boiling the water for 3 methods. This method produced results better than methods 2 and 3. After boiling, the ammonia concentrations was most similar to drinking water at 0.25 ppm for the pond water and calcium chloride water. The only downfall was that the concentration of total dissolved salt and electrolyte went up after boiling. This can be explained by the fact that water evaporated, but the solids remained, making the numbers high as there were more solids than solution concentration. And then the cost ranges from if you use a kettle, if you use a fire. So after they were all scored, the total rank for each technique was totaled, and the methods with the lowest score was determined to be the best method. The carbon filter received an 8 in making it the most cost-effective and efficient approach. The iodine and bleach rank a point difference after the boiling process. Such knowledge may be used for developing countries that lack access to clean water by making filtration more accessible or by employing these filters as temporary solution until a long-term solution is identified or accomplished. For the future, the following steps would be like figuring out ways to test for bacteria in the water and determine if these methods can get rid of it. Bacteria is a significant factor that affects the safety of water. Knowing if there are bacteria before and after each method is crucial to determine the quality of water. An important bacteria that should be tested is for E. coli that comes from water contaminated with feces. Other future research would be determining if the bleach and iodine could be removed after being added to the samples. And future research that also could be tested on is how to make these methods more accessible and determine a plan for countries to use methods that do not have access to safe or clean water.